What's up, everybody? As you can see, I have done some work here to this thing. I've got all of these relays wired in, and I added an extra board right over there. So I've kind of, today's lesson is just going to be on how easy it is to actually do and wire up, relays, switches, just various other things. It may seem complicated, but it's not that complicated, and I will be glad to show you. Oh, I took the alarm out of the equation right down there, but as you can see, let's see here, we got 26 volts AC. 12 volts DC. Everything's good, right? So, and again, this is just a very easy, just simple, I don't know what's the words I'm looking for. It's not about what I did, it's about just thinking and using the process. And basically I'm using this contactor, that relay, that sequencer, that relay, and it's not about having 24 volt stuff wired up. It's about just using what you know or what you've learned to be able to accomplish what you want to do. And basically how this is going to be is when I flip the hand, it'll close a contactor, and then it'll in turn start energizing relays. And the way I wired it up is it will go to the sequencer first, and as the sequencer makes, that'll energize this relay, it'll energize that one first, and then it'll energize that one as the sequencer goes. But again, that is not particularly the point. The point of this lesson, I guess, if you will, is that this stuff is not as complicated as you think it is. So let's see here, find common, and how am I going to do this? Let's see. Sorry guys, I don't know if hopefully you can see that, but we have no voltage, nothing, right? Absolutely nothing. And I have them going through this contactor. No voltage. I do have 26 volts sitting at the top of this one. Cool. And this one, nothing. Huh, why is that? Well, because of the way I wired up the HOA switch. Got voltage sitting there, but it's obviously not going through because the contactor is not energized. And I also ran them through these relays, ran them through this board. So it's not the way I did it. The point is just to think about things. This stuff can seem very daunting, and I understand that. And it used to be very daunting to me too. But this funny thing about this trade is it's one of those weird things. It's hard until it isn't. And once the ding light bulb goes off, this stuff starts to get quite a bit easier. So let's try this out. When I go to hand, this contactor will engage, and then we'll test things out. Okay, contactor's engaged. We'll grab common. 26 volts, right? This wire goes down to the coil of this relay. The green light right here is illuminated. We have 26 volts. Now let's come to the top side here. I don't understand that. Oh, duh, I'm on the wrong wire because I'm an idiot. Boom, 26 volts, right? So it comes out of the normally open here, comes over to the common terminal of this relay board. So again, grab common. The common terminal, which is not the same thing as common on the 24 volts. The common terminal on a relay, all that simply means is it's common to normally closed and common to normally open. Think about it as a pendulum swinging or something like that. You have common, normally closed, normally open. It's just doing this, but it's still the common point between here and here. So we got 26 volts. Fantastic. Well, if you're paying attention and you're listening, you didn't hear that click or thud that you normally do. Let's check a contactor. No voltage. No voltage. No voltage. No voltage. No voltage. No voltage. Jason, I thought it was going to work. Ah, but it will. So this relay right here, the contacts are 12 volts DC. And I have wired this up through my potentiometer right here. So let's go ahead and give this some voltage and take a listen. You'll start hearing the 24 volt stuff energizing. Boom. $26 volts. Nothing there yet. Why is that? Nothing there yet. Why is that? Oh, I'm on the wrong side. 26 volts on the sequencer. Yeah. Boom. I think we just kicked in another one, right? So now we should have 26 volts here. And we do. That relay's energized. Well, what about this one? That one too. So that's kind of the lesson. Now watch this. I stick this in here. Try and do this one-handed. Stick this in here. Hopefully you can see that. 26 volts. I'm going to de-energize all that, even though I'm in hand, right? Even though my contactor's engaged. I'm using this relay as just another way to turn stuff off without killing power and etc. Again, it's not what I'm doing. It's just the lesson is to think. There we go. We lost it. Okay. Well, that handles that. Now let's flip her over to auto and see what happens, which will be these contactors engaging. Bam. Okay. Now let's see what happens. 26 volts. 26 volts. 26 volts. 26 volts. 26 volts. Nothing up here. Nothing up there. Neither one of these relays are energized. I staged these relays through the potentiometer, which would activate this one, which would then activate all those. This one will illuminate when we go into hand. Okay, light's on. This light is not on. Let's go ahead and activate it. Bam, there it goes. Again, it's not what I did. It's just using what you know to accomplish what you want. And that is kind of the goal of this. Hopefully you guys enjoyed this. I mean, I'm just having fun with this stuff. And I look at this as, you know, I mean, yeah, I mean, I wired all this up. So obviously, I hope this doesn't come across as arrogant, but I mean, I know how to do this. But this is still good food for your brain, you know. Makes you think, makes you wonder, makes you start exploring what's possible and what's not. Hopefully you guys got something out of this, and happy HVACing.